All right, here's hoping this works. Is the audio coming in clear as well? And yeah, let me know if you can see the text reasonably well on the screen or not. Otherwise, I'll zoom in or something. And there is a little bit of a delay, so that's why if it seems like I'm slow. Hey, I can see the text. Perfect, 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 perfect. Seems fine to me. Wonderful. Okay, perfect. So I suppose what I'll do is I'll just start going over some of the simpler ones. Again, simple doesn't necessarily mean trivial. It just means, we'll go back a couple of weeks in the course talking about conditionals, do some of these. These are like your if statements. And then we'll just go from there. If you find that, let me make sure. Yeah, okay. If you find, if you have questions along the way, absolutely ask questions. If the group seems to think that, okay, well, these are dumb questions, go do other questions. Yeah, just let me know. I'll happily do a specific exercise if there's one you got stuck on. I want you to note, though, the first thing I got to say before we get going is knowing what the answer to any of these questions is not going to help you. What's going to help is knowing and doing and like actually knowing the process. Because if you can't sit down, read the question, and then solve it, but have a whole bunch of answers to the exercises memorized, that's not going to do you very much good. So anyways, yeah, we'll start here. I am on, let's check it out. Yeah, conditional. So this is number 5 of the online text. So here we go. I mean, I'm going to skip some of these. Some of these are talking about things like truth tables and whatnot. And like, what do these expressions evaluate to? Like, I mean, we can do these real quick. But let's start up here. Assume the days of the week are numbered 0, 1, 2, 3, 4, 5, and 6 from Sunday to Saturday. I guess this just assumes that the first day of the week or the 0th day of the week is a Sunday. So we need to write a function which is given the day number and returns the day name, a string. Okay. So I suppose what I'll do is, let's be fancy. There. Okay, so function name, def get day name, and then there we go. Perfect. This seems like a sufficiently good function name. And okay, so I guess it's just going to be a series of if statements, right? So if it's 0, then return Sunday. If it's 1, Monday. 2, Tuesday. Okay, so if day number, I'm just going to copy this because we're going to be writing this a lot, is 0, return Sunday. Now, here, you might be wondering, okay, should we do an if or an else if? We're not going to want an else, right? Because an else is like one of two options. We're either going to run this or that. The else ifs is a way to make the thing like exclusively one of the things in the string of a string, in the series of if statements. But the trouble is going to be, well, it's not trouble. It's just we don't actually really need it here because we're only checking for equivalency, and if the numbers are only 0 through 6, we should be pretty good. Also, even if there was like a way of going like where it would check all the ifs, if you just had a series of ifs, I wouldn't be too worried because in the function, as soon as it hits return, we're going to be done the function anyway, so we're not at risk of tripping any of the other if statements. So we don't need to worry too much there. But if we want to get fancy, we can do some elifs. So elif, if day number is 1, return Monday. I'm just going to copy all of these. Tuesday. Wednesday. Thursday. Friday. And I suppose I have a question. Yeah. So I'm hoping to, I'm recording the stream and I'm hoping it's gonna work just fine, but also I turn on video on demand, so hopefully it'll also work. So LF day 5 and LF day 6 is, Saturday. Now, I could have done else, right, if the last day of the week is, if it's not 0, 1, 2, 3, 4, 5, then it should be 6, the Saturday. So I could just do an else, like just like that, and it would be fine. But I'm gonna do it like this, because then I can say, just as a way of just addressing anything that isn't like a proper number, because maybe someone like they fat fingered it or something. So I don't know. So there we wrote our function, and now let's see, print get day name. There we go. And I don't know. Let's test it with 0. It should give me back Sunday, right? Hey, wonderful. So let's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then there we go. Wonderful. Wonderful. Okay, so there we go. I mean, it looks like a long one, but really it's just a series of if statements. And like in some other programming languages, and I think you can do it now in Python, there might be a cleaner way to do this, but we're not going to get into that right now. And of course, if there's any questions about anything I'm doing so far, absolutely, just throw the question in the chat. Happy to see if we can dig into it. There we go. Okay, perfect. Excuse me. Oops. So, okay. So you go on a wonderful holiday, perhaps to jail if you don't like happy exercises. Leaving on day number 3, a Wednesday. You return home after 137 sleeps. Write a general version of the program which asks for the starting day number and the length of your stay, and it will tell you the name of the day of the week you will return on. Okay. So, and it will tell you the name of the day of the week you'll return on. Okay, so let's copy this. This one's actually kind of a tricky one. Whoops. Come on. There. So with this part here, and the length, and it will tell you the name of the day of the week you return on. This one, we should be able to make use of this. Or pardon me, make use of it. We should be able to make use of this function there. Right? So for simplicity, I'm not going to bother with the like, oh, you get an input, whatever. We'll just define the parameters, right? So start day number equals whatever, and then number of nights equals 137. And I guess it was a 3. What was it? 3. A Wednesday, 137 sleeps. Okay, so let's think about this one. Because the example they give you here, I think, is a little bit misleading isn't the right word, but they give you an example that might seem more difficult than we would really want. So let's simplify this. So let's say it was, okay, could you possibly save the live stream afterwards so we can watch it later? Yeah. It'll be a video on demand, and I'm going to hopefully upload it to YouTube. Assuming the recording works just fine. So let's think of it this way. So if we slept one night, that would be 4. 2 nights, 5. 3 nights, 6. 4 nights, we go back to we go back to Sunday. So we need a way to have it loop back. But of course, you might remember that fancy operator that we used. Now, we only really used it for playing around with checking if a number was even or odd. But that percent sign, that modulo operator, was really handy at showing us what the remainder is. So I suppose the key here is if it's day 3 and we stay 4 nights, that would get us to day 7. That's the sum of these two numbers, right? So, what should we call the next variable? So, start day plus nights equals start day number plus number of nights. Okay, and when in doubt, throw a print statement in there, right? Or print function. Print. Okay, so if we did this, that's a 7. If we stayed 5, that's an 8. But an 8 should be Monday. So this seems a little tricky, but you might remember, if you ask yourself the question, and this one, the trick is being familiar with modulus, the percent sign, modulo, or whatever, however you say it. If you are doing, what's this? Suggested video. What? Well, no, now we can watch that video later because it's not really a good time to watch video. So if it was 8, so what's 8 divided by 7? Like, how many times can we get 7 out of 8? Well, we can get 1 out, like 1 group of 7. And what's the remainder? 1. Let's go back here. 7. How many times can we get 7 out of 7? Well, exactly, 1. I see you answered it there. Good job. So how many times can we get 7 out of 7? Well, once, and the remainder is 0, which is conveniently the day of the week I want. So let's just throw in %7. And 7 makes sense because, you know what, let's get, I don't know, overkill here. And we'll make a constant called days and week. Only because perhaps this is a little bit more self-explanatory. Perfect. And so if we started on day 3, slept 4 nights, that would get us a total of 7 days. That would get us to the 7th day, which if we're counting from 0, that would be like 0, 1, 2, 3, 4, 5, 6, 7 would go back to 0, which is right. So Wednesday, Thursday, Friday, Saturday, Sunday, and Sunday 0. If it was 5 days, that would be the Monday, Tuesday, and then of course if we stayed a whole week, that'd bring us back to the Wednesday. So it looks like this mod might actually be doing the trick here. So let's put this into a variable. I mean, perhaps it's overkill to put it in a variable. I realize we can do all this in like one line of code, but you know, to keep it, sometimes it's nice to write like verbose code that really explains itself. So what should we do here? So what should we call the next thing? Plus nights. Day, number, day of week. Maybe result. I don't know. That's not a particularly good variable name, but it'll be this. So there we go. And then print. Okay, cool. 3. Okay, so that checks out. Now, of course, we don't want to just print out the number, though. We want to get the actual name day. So, I mean, the convenient thing here is, oops, we could take this and just use the function from before. I guess it'd be a Sunday if we started on, I mean, I hope so. Sheesh, I don't really want to count 135 days. What day of the week is 137 days after a Wednesday? A Friday? Oh, but is that... I'm not sure that's... What? It looks like it's asking from today. So if today... So, wait, how do I use this website? 137 days from... Just pick an arbitrary Wednesday. Calculate. Sunday? Is that right? It looks like it. I don't know. Let's... All right, cool. Okay, go away. Summary. All days included. Oh, I see. This is like if you're excluding weekends. And okay, cool. All right. So it looks like it worked. Okay, let's go back. So what is the opposite of these conditions? Well, if we don't want A greater than B, then it would be A less than or equal to B. Here, be less than, I forget. So these two here, what does this evaluate to? Now, a lot of students, when they're just learning out, get thrown off by this because you're used to seeing these Boolean expressions a lot of times in the context of like a condition for like your if statements or your loops or something, like a while loop. And you kind of lose sight of the fact that this is an expression that gives you results. Let's go back here and just to show you here real quick. If I do this, like it's true. That is something that gets equals is yes. And it's a question about, is it equivalent or not? And it's going to be a true statement or false statement. So yes. So there we go. 3 equals 3. Well, that's true. 3 is not equal to 3. Well, that's false. Is 3 greater than or equal to 4? False. And then 3 is less than 4, which is true. But then we not it. False. All right. Let's do this one. This will be the last one for conditions I think I'll do. And we will move on to the next one from there. So let's go. Let's say text. Okay, that is terribly formatted. There we go. Okay, text. All right. So, write a function. So def get letter grade. First, upper, second. Oh, I guess these are like English grades, I think, right? Is it? Ooh, and I guess there's like multiple in England. There's like multiple levels of failing, I guess. Oh, that's terrifying. So not only do you fail, like they let you know how bad you failed. All right, get letter grade. So I guess it's not a letter grade. It's the grade for the mark according to this scheme. I'm gonna call it letter grade just because that's what I'm used to. But for the fun, we'll follow what they're saying here. So, all right. No. Mark, whatever. Okay, so if mark is greater than or equal to 75, return first. Okay. So this is going to seem a lot like the first one. You know what? I'm going to write this one a little bit differently. I'm going to make it so we create a variable. There. And then if 70 to 75, so we'll just do 70. What is it? Upper second. Whoop. There. And then 60 to 70. Wait. Yes, 60 to 70. Second. Third. And then 45. What do they call it? F1 sup? I don't know what that is, but okay. If it's greater than 40, we'll call it F2. And if it's, we'll say greater than 0, F3, else letter grade equals, there. Something like that. Keep it nice and simple. But the difference here is what I'm doing is I'm creating a variable. And then depending on the depending on the condition, what I want to do is assign the string, the appropriate string to the variable. And then in the very end, down here, I'll do return letter grade. There. Now, I want to be very clear. Like, it doesn't matter, right? Like, I could have made it return here and return here, return here, but I wanted to do it this way for the fun of it. So of course we wrote it. There we go. This line in Python 2 up here at the top is unnecessary, but I put it there just because I kind of like creating my variable before I use it, just in case. Okay. And so let's test it. Get letter grade mark, print. Okay. So let's say they get like -1. Let's see. I don't know what happened. Okay, that makes sense. Let's say they get 36. F3, that's correct. Now let's see what happens if they get 78. F3. Does anyone have any idea what went wrong here? Remember, the one magic rule is, what does the code say? So, like, type in the chat if you think you've got an idea as to what went wrong. And while I wait for that, I am going to click that YouTube link to see what it is. Oh my gosh. Why did you post that? All right. Can we ban who is hack? All right, so if you're stuck on this one, the trick here is the problem is we're just using a series of if statements. And let's go through and think about what this means. So I entered the grade 78. So okay, we jump in here, mark is 78. Letter grade starts out as this empty string. And then I ask the question, is mark, which is 78, is it greater than or equal to 75? Which is, of course, true. So, therefore, I go letter grade becomes the string first. Okay. But then it just goes to the next if statement. And it asks, is mark, which is 78, greater than 70? Which, of course, it is. So, it replaces letter grade, which was first, but now it says upper second. And then mark is also greater than 60, and so on and so on and so on. So that kind of like gets pushed all the way down to the bottom where it gets to this. And we skip the else because this if and else are stuck together. Exactly. So the easiest fix here is throwing the elifs instead, which of course makes our if statements now like exclusive. They're like mutually exclusive. Only one can run. So let's do this test again. First, there we go. So we're good. So Davin got it right because 78 is greater than 75, therefore it's first. But then because it's in this chain of elifs, it just goes, well, I ran this one so I can skip all the other ones. So there we go. Cool. All right. Let me have a quick look here to see. Yeah, it doesn't look like. Okay, cool. So there, we finished conditions. Pardon me. We finished the ones I want to do for conditions. Functions. Okay, looking at the time, it's 7:30, 7:27. I'll ask the chat, do we want to go into looking a little bit more on functions, or do we want to just jump to like iteration, like the loops? Someone's got to say something, and we'll go with whatever the majority is. Can we go to chapter 6? Chapter 6, fruitful functions. Okay, perfect. All right. So, what is this saying here? Languages. Okay. My goodness. All the way down to the exercises. All right, exercises. This chapter showed us how to sum a list of items. Oh, wait, I went to 7, not 6. Let's try this again. All right. Oh, look at this. All right. So, all the exercise below should be added to a single file. In that file, you should also add the test and test suite scaffolding functions shown above. And then, as you work through the exercises, add the new test to your test suite. If you open the online version of the textbook, you can easily copy and paste these tests. After completing exercise, confirm that all the tests pass. So this is interesting. This one here wants us to... Oh, I realize how terrible the Twitch chat looks on the white background, but sorry. So this wants us to do some testing here. Perfect. Look at this. So unit testing. Now, we haven't gone over this in class, but this is basically kind of like it's giving you like a paradigm or like a framework on how to think about testing your code. I think I'm going to... For the time being, run the suite of tests for code in this module. For the time being, I think I'm going to skip over doing the test part just because I don't want to distract from the stuff that would be on the midterm or would possibly be on the midterm, right? But that's interesting nonetheless. So hopefully some of you have gone through that. All right. The 4 compass points can be abbreviated by single letter string as NESW, northeast, southwest. Write a function, turn clockwise, that takes one of these 4 compass points as a parameter and returns the next compass point in the clockwise direction. Okay. Oh, okay. So here they're saying, so if it's north, it should be east. If it's east, it should become south. If it's south, okay. All right, cool. Now, I think they're calling this section fruitful functions because these are functions that are returning a value. The ones I was doing before was returning values, but maybe they just wanted us to print it out, but whatever. All right, so let's go here. Copy this. And we'll add text. Okay, there we go. All right, def. Oh, turn clockwise. They actually gave us the name. I wonder, can I do this? Ah, nice. All right, turn clockwise. Direction. Okay, so I guess it's just going to be a series of if statements again. If is equal to north, return east. Okay, yeah. Northeast becomes south. I guess we could make these elifs as well. Even though it's not necessary, but whatever. If it's south, it becomes west. And if it's west, it becomes north. And then finally, else. Return none. Okay, cool. All right. So let's test it. Turn clockwise, and we'll give it north, east, east, south, south, west, west, north. Hey, wonderful. Remember, if there's a specific exercise that you were working on before and you just want me to go over it, let me know. All right. Write a function. So that one works here. And then, yeah, this is the returning none. Cool. Write a function day name that converts an integer number 0 to 6 into the name of a day. Didn't we just... Wait. All right. Well, I'm just going to... We already kind of did this one. Day number. Yeah, okay. I'm just going to copy this because it already exists. Actually, I guess I don't even really need to copy it because it's there. Do they say what they want it called? All right, day name. All right. I will copy it and I'll just rename it because there is a slight difference where they wanted us to return none. So, okay. Oops. Okay. But I will be lazy because we already wrote this code. All right, there we go. And down here, there, it wanted us to do none. And what was it called? Get day name. Oh, wait, no, they wanted it to be called day name. Okay. Sunday, Monday. I'll just go to that. None. All right, cool. There we go. So this is just the same as the other one. Write the inverse function of day name, which is given a day name and return its number. All right. I think I'm going to skip this one because it's just going to be more of the same. It's just going to be a function, except instead of checking the numbers, I'd be checking the strings. So it's too similar. I'll skip over it. Write a function that helps answer the question. Today is Wednesday. I leave on holiday night. Okay, this is the same as what we did before. So I'm going to skip this one as well, just because it's the same as what we did from the previous one about the conditions. Can your day add function already work with negative deltas, for example? Ooh. I am curious about this. Okay, what was that name of that function? So I'm going up to here, which is this question from conditionals. And I'm curious if it will work. So if days a week, start day -1. So if that's a Wednesday, Tuesday, hey, Monday, Sunday. Here's the big test. Uh-oh. Wait, was that right? 3, Sunday, 4, Saturday. Wonderful, it works. Haha. All right, we got lucky. All right. Write a function days and month, which takes the name of a month and returns, oh my gosh. Okay, this is just a whole bunch of ifs with return values. So Davin, let me know if there's a specific one in here you wanted me to do, or has this been sufficient, or just let me know. Write a function to secs that converts hours, minutes, and seconds to the total number of seconds. All right, we could do this one. So essentially, if you do negative, it does it in reverse. Okay, so I think what's going to happen is, let's think about this one. So we'll take a second and think about this question you're asking, but I don't want to go too far into it because the specifics of this type of operation is not going to be overly important. You know, this is kind of like a forest through the trees scenarios, but yeah, let's talk about it. So I guess really at the end of the day, it's just the sum of these two numbers. So if the start day is 3 and the number of nights is -4, well, 3 plus -4 is -1. So -1, well, how many times can we get 7 out of -1? Well, 0, but we've got that like -1 remainder. So -1 remainder, that's interesting. So I guess it loops back. So -1. How does mod work with negative numbers? It's too late in the evening for me to wrap my brain around it. So whenever I'm in this type of scenario, I just am going to play with some numbers. So what is -1 mod 7? That's 6. Oh, okay, I think I see. So it's like if we were going... Yes. Okay, maybe you see it too. So if it was 0 mod 7, 0, 1 mod 7, 1, 2, because this is saying 2. All right, how many times can we take 7 away from 2? 0 times. What's left over? 2. If we do -1, how many times can we take 7 away from -1? Well, 0 times. But if we had, that would get us like to -7. And then we have the remainder would be the 6 from that -1. If this doesn't make sense, don't worry about it. I absolutely am explaining this poorly. But again, this isn't going to be overly particularly important for Wednesday. It was more just kind of showing you, you know, we're doing conditionals with some extra logic in there. You sort of get it? Yeah. If you're like me, what I'm going to do is say like Python. Let's have a look here. Yeah, sure. Looks right to me. Okay, unlike CRC, Python modifier always returns a number having the same sign as the denominator. Your expression yields 3 because -5 mod 3 is 1.5. Floor of that -2. What? All right, I don't want to do this right now, so let's not worry about it. This is just distracting us from having some more fun with the other exercises. All right, okay, let's do this one. Write a function to secs that converts hours, minutes, and seconds to the total number of seconds. Okay. This is going to be basically, this is going to be exactly the same as one of the questions on the assignment, except now we're thinking in terms of like hours instead of like degrees, minutes, and seconds. All right, so def secs. Okay, perfect. So the seconds, okay, total. We can start it at just seconds, right? But then it would be total seconds. So total seconds So let's say let's think about through it. So let's say it's like 5 hours, 21 minutes, and 55 seconds. We know we're going to need these 55 seconds in there. So I'm just going to throw it in with just like, okay, total seconds starts at 55 seconds. And then to that, we will add the total number of seconds from the 21 minutes. Now, how many seconds are there in a minute? Well, there's 60 seconds times the number of minutes. Because if there's 21 minutes, well, it's 21 times 60 to get the total number of seconds. And then here, times hours. And return total seconds. So I could do 3,600 or whatever, I guess, but there's 60 minutes in an hour and 60 seconds in a minute times the number of hours. Okay, let's test it. And let's see if they gave us some examples. True, hey. True. Okay, cool. All right, so now we're at 7:43. Do you want me to keep going in the in this function section, or do you want me to jump to loops? I'm going to recommend we jump to loops. Yeah, let's go to the next one. So iteration. Let's go all the way down. Okay. Ooh, what's going on here? What? Okay, whatever. Okay, write a function to count how many odd numbers are in a list. Perfect. This is a great one. You're fine with, okay, cool. So write a function to count how many odd numbers are in a list. Okay. So this one is by far the most complex one we've looked at so far. Okay, so, oops. Okay, write a function. Okay, def count odd. Okay. And okay, so here we go. And I'm presumably going to return that value. All right, so if I have a list, just to be overkill, I'm going to write another function called isOdd that just takes a number. And it'll return if n mod 2 equals 1, return true. So remember, n mod 2 is a great way of checking if it's even. Is 0 divisible? How many times can you get 0 out of 2 out of 0? 0 times remainder 0. How many times can you get 2 out of 1? 0 times remainder 1. 1's odd. How many times can you get 2 out of 2? 2, remainder 0. 3, well, you can get 2 out once, remainder 1. So whenever you check something mod 2 equals 1, that tells you if it's odd. Else, there, perfect. So this is a little helper function I've written here, isOdd, that just tells us if a value is even or odd. I could very easily write this within this function here, but just because I wanted to do it as a separate function. Now, I know I did talk about this in class, and you might remember, but we can actually replace all of this code here with return n mod equals 1. this might seem like I'm like skipping some steps, but it's not. Just think about this as an expression. Remember, these are expressions. These are Boolean expressions that get evaluated to a Boolean. So let's look at the original one. So I'm saying if n mod 2 is equal to 1, and let's say that this condition is true, then I would return true. If that condition is not true, thereby being false, I would return false. Well, this is effectively saying if true, return true, otherwise return false. But if I just say, well, evaluate this, and whatever the result is, if the result is true, then I know it's odd. If it's not true, it's false, then I know it's even. So I could just replace all of this with that one little line of code, and it's a little cleaner. Nothing logically wrong with doing it the long way. In fact, maybe at this stage you like to do it the long way because it's more verbose, more self-explanatory. That's fine, that's fantastic. But I'm just going to do it this way because I like it that way. So, a list. Okay, I've got a list. And I'm definitely going to want to iterate over that list. And we've got a couple of options because we have a couple styles of loops. We've got a while loop, we've got a for loop, and we also saw how we can kind of use a for loop in multiple ways. Like we saw enumerate, we saw the for loop where we use like the range of the length of the list. And we saw the for loop where it said like for each thing in the collection of things. The while loop usually we use like a counter variable in a scenario like this. But I think in this particular case, I'm going to use like the like for each style for loop. So for n in for a number in a list, I'm just calling this a number because whatever. The fact that this is a number and a list is entirely coincidental. So if is odd of a number. So if I call this function and it returns true, this is if true, then I would execute this code. So I'm going to start a counter at 0. So if it's odd, then I'm going to count it. If it's not odd, what do I want to do? Well, I guess I would do nothing. So in this particular case, I really don't care. I'll just do, if it's odd, count it, and then carry on. If it's not odd, whatever, I don't care. But then, so remember, we got to be careful with our indentation here. Because, look, I can't, like, if I did return counter here, let's see what happens. So if I do print count odd of, so there's 1, 2, 3, 4, 5. There's 5 odd numbers here, right? So if I call this, I should see 5, but I only see 1. Here's why. Remember, the one silver bullet trick is follow the code. What does the code say? All right, so I pass this list in. Okay, counter starts at 0. A number, the first number in this list is 0. Is 0 odd? No. We'll assume this is correct. It is. Is 0 odd? No. So we skip this function, or this part of this if statement, and then we loop back, and then a number becomes the next number in that list. So it's 1. So 1. Is 1 odd? Yeah. Great. So we go inside this if statement, we increase counter by 1, and then we return counter. Well, that's no good, because remember what happens as soon as we hit a return statement, the function immediately stops executing and it's done. It's done. That's it, which is no good. Highlight my in case, is it case return ends it? What? Is it cause return ends it? Yes, it is because return ends it. Absolutely. Pardon me. I misread it. I misunderstood what you were saying. And that's exactly it. It's because we returned and then the function just stops, and that's no good. So, okay, maybe we should unindent it. And if we run it again, now it comes up as 0. Well, what the heck's going on now? Well, let's look at the code. Remember, there's no magic other than what does the code say? There, just for a little readability. So counter starts at 0. A number. Well, a number starts at 0. Is 0 odd? No. So we skip this and we go here. Oh, the return's in the for loop. So as soon as the first iteration of the for loop is done, we immediately stop the function because of the return. So I want to return after the for loop, because that would mean that if the for loop ran every single time it's running for each number in this list, I can't return the value of the counter until I've looked at everything in that list. So the return should be outside that for loop. So let's see now. 5. 1, 2, 3, 4, 5. Looks good. So let me know if there's any questions along the way. Remember, looking at what I'm doing and following along is great and all, but if you can't do this on your own, you're going to be in a tough spot. And I know I sound like a broken record. I know I've said this a lot in class and in lab, but you can go watch every single tutorial there is on the internet. You can watch every single lesson video on how to play piano. And unless you actually sit down in front of the piano and practice, you can't play piano. You could watch 1 billion years worth of videos, but you're not going to be able to play piano at the end unless you actually play piano. All right. That's a good one. So sum up all the even numbers in a list. All right. This one's going to be very similar. So let's add some text. Okay. Sum up all the even numbers in a list. Okay. So, okay, I'm going to do this one, the even one, except I'm not going to do it with this extra like fancy help function. So def sum even a list. Great. So what do I need? Well, I'm going to want a for loop because I need that for loop to go through and put its finger on each element in that list. And what do I want to do with each element? Okay, well, I want to check if it's even. All right, how do I check if it's even? Well, if a number mod 2 is 0, it's even. That's when it's even. Basically, if it's evenly divisible by 2, if you can divide it by 2 and the remainder is 0, it's even. Because that's like the definition of an even number. There's a free hydrate. All right. So it's even, then what? Okay. Sum up all the even numbers. Well, we'll need a running total. Right? Because what I'm going to do is, if the number's even, I'm going to add to the running total the number. So running total plus equals a number. And remember, if at any point, remember that plus equals is shorthand for this, saying running total equals running total plus something. So just remember that. And then at the end, we're going to want the return outside the for loop, not in the if statement because it'll stop immediately, not outside the if statement, but in the for loop because then it'll just stop. And then outside the for loop, in the function, of course, the return's got to be in the function, but we want it to be outside the for loop because outside, but after the for loop, because that's when we know that the loop has put its finger on each element. So return running total. Okay, now I'm just going to take this code here, do sum even, and we'll hit run, and the value is 20. Well, does that make sense? So 0 plus 2 is 2, plus 4 is 6, plus 6 is 12, plus 8 is 20. All right, cool. Now, when in doubt, whenever you're left going like, oh man, maybe this wasn't working, Or maybe this is working, but you're still going like, but wait, what? The silver bullet, what does the code say? But to help you answer the question of, well, what's the code doing? What's the code saying? Throw print functions in there. Print, let's print out running total, followed by a, there. So what I'm asking it to do is, at the very beginning of the loop, every single time that loop executes, I'll print out running total and what the number is that I'm currently looking at. If it's even, I add to it. If it's odd, I ignore it. And then it'll go back up to the loop and then tell me the running total again and a number. So I should see, if you think for a second, I won't say the answer immediately, but think, if this loop has, or pardon me, if this list has 10 things in it, how many times, like how many lines will be printed out? Okay, so I'm gonna hit run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. This last 20 is the print from this line. The result that got returned and then printed out. So it ran 10 times. First time through the loop, 0 and 0. Great. Next time through the loop, running total is 0. Well, even 0, but it doesn't add anything to it. And then 1. 1's not even, so we skip it. 0 and 2. Well, 2 is even, so the next time running totals, now that, but it's looking at 3, do nothing, 3, 4, it's 6, and so on and so on and so on. So when in doubt, throw a print function in there and it'll help. All right. All right, let's see. We're getting to the end of the length of time I wanted to do with this one, but what I'm gonna do is maybe we can have a quick look through here to see if there's a particularly good one. Count how many words in a list have length 5. Ooh. Sum all elements in a list up to, but not including, the first even number. Oh. Count how many words occur in a list up to and including the first occurrence of the word Sam. Add a print function to Newton's square root function that adds whatever. Trace the execution of the last version. Write a function, print triangular numbers. That prints out the first n triangular numbers. A call to the first would produce the following. What? What is a triangular number? Use web search, found a triangular number. Triangular number or triangle number counts objects arranged in an equilateral triangle. Oh, is it the sequence 1, 3, 6, 10, 15, 21? That's a good one too. All right. Which one should we do? Should we do this fancy triangle one, which is a little harder, I think? Or how many words in a list have length 5? You know what, let's do both. Because this one's actually not too bad. Okay. Okay. All right, def count len 5. Okay. A list. All right. Okay, so I'm supposed to count the number of words that are length 5 in a list. So I'm gonna need this running total thing again too. Or I'll just call it counter. It starts at 0. And for word, you know what? I'm gonna do it with the I this time, just because. Like for I in range, len a list. There. So now I'm using a for loop in a different way, where what I'm gonna have is I be 0, then 1, then 2, then 3, then 4, and then I'll use the I to index a list. You could totally do it with a while loop. You could totally do it with You could totally do it with a while loop. You could totally do it with a for loop where you're just saying for each word in the list of words as well. Like totally, in fact, you're probably better off doing it that way, but just to be different this time, I'm gonna do it this way. So what's the question I wanna ask? If the word is length 5. Okay, so if, now we need to get the individual word. Well, we'll just take a list and index it. So we want a list at I. The first time through the loop, I is 0, then 1, then 2, then 3, and it'll go all the way up to, but excluding the actual total length of the list. So it'll put its finger on each thing in the list. So if the length, though, because remember, we can ask the length of a string, and this right here should be a string if the person is using the function correctly. So this is the length of a string. This whole thing. So a list is a list of strings. A list at index I is a specific string in that list, and then I'm asking the length of that. Oops. And then if the length is 5, what do I want to do? Well, counter plus equals 1. If it's not 5, do nothing. And then, of course, return counter. But the return counter is outside the for loop because I can't return a value. I can't know the answer to the question, how many words of length 5 are in this list, until I've looked at all the words in that list. So let's do word list equals hello world 5 letters 1 2 3 4 5 fun 1 2 3 4 5. Great. So this is 5 letters, 5 letters, 5 letters. So we should see 3, I think. So print count len 5 word list. 4? What? Oh, world has 5 letters in it too. Oops. Well, there you go. I guess it's good that the code was right, but not good that I can't count. So that's nice. All right. Okay. Is this helpful? Like if I'm going too fast, pause or whatever. I realize this is a live stream, but there'll be the VOD and I'll upload this to YouTube so you can reference it later and you can pause. Because I realize maybe I'm going quick because I'm trying to cover a lot in a short amount of time. But remember, like you can stop me, ask a question or whatever. Very happy to see questions and whatnot pop up in the chat. So thanks, Davin, for participating. This is great. And yeah, so now the last one I think I'm going to do is this one. Write a function to print the triangular numbers. I like this one. This is a good one. Because I think this is probably the most complex function I've asked you to do, that we've seen to date in 161. So, oops. Here I can plop in the code, def that, cool. All right, write a function. Okay. And then the triangular numbers are the numbers of the total numbers in a triangle. The total number of things in a triangle that would make up like the equilateral triangle. So it starts at 1, I guess, does it? Yeah. And then 3, because you'd have 1 dot followed by 2 dots, and that's 3. And then the next time there'd be 3 more on the bottom to make it like a nice equilateral. Here. Ooh. Let's take size, gigantic. Okay. It would start at 1, and then if we want to continue with the triangle, we'd add 2 more to the bottom. I guess having 1 isn't a triangle, but we'd have 2 more at the bottom for a total of 3. Next time down, we'd have 1, 2, 3. Now we've got 1, 2, 3, 4, 5, 6 things. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. 1, 2, 3, 4, 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 16, 17, 18, 19, 20, 21. All right, cool. So it looks like that's the idea. Now, I think that this question is probably a lot easier than you think, but let's work through it, assuming it's not easy. All right. All right, so I want, okay, so it's up to 5. So I'm going to need a running total. I'm going to do this with a while loop. So I'm going to do a while loop with the counter C. C is less than N. Actually, let's start it. Yeah, okay, that's fine. Okay. And then C plus equals 1. There we go. Are there ads? I didn't add an ad. It's Twitch. Blame Twitch. I can give you an ad if you want. There's a button I can press, but I won't do it. All right. So here we go. So we'll start, we'll need a variable also for, I did. I can, after I finish this one, I'm going to play an ad while I go pee or something, and then I'll come back. All right. I'd pog up for increased, what? I don't know what that means. All right. Well, C is less than that, and we're going to increase counter. So I've got my scaffolding for my while loop here. Now the triangle numbers, if we go back to Paint, the first time through the loop, the first time through the loop, I'm going to call them rows. So I'm going to call each point like a row. So this is a row. Well, let's make this smaller. This is a row, this is a row, this is a row, and so on. So current row, we'll start it at 1, right? And I'm starting it at 1 because, well, the current row starts with one thing in it. So then what I'll do is I'll say, okay, total triangle numbers is equal to itself plus the number of points in the current row. Does that make sense? So the first time through the loop, okay, there's nothing in there. And then I look at the first row. And how many things are in it? One thing. Great. But I need to loop again. But how many things now? Like the next row, I joined late clearly. What is the triangle number? It is, I had to look it up too. It's basically, it's, okay. I'm going to go through it the complicated way, and then this is a triangle number. Maybe this picture will kind of show you. It has a sequence number. It's 1, and then add 2 points to the bottom for the total is 3, then add 3 points to the bottom for the total is 6, and so on. That's what a triangle number is. So there we go. So now we've got current row. Okay, triangle number starts at 0, then we add the total number in the current row. Then if we look here, there are 2 things in the next row. So current number needs to become 2. And actually, it looks like each time we go down, we only add 1 to the number in Pascal. I don't think so. No, I don't think it's Pascal's triangle. Pascal's triangle is like when you like sum down, I think, right? It's been a while. I can't remember. But yeah, each time I go down a row, I increase the number of dots in a row by 1. So I can just say current row plus equals 1. Right? Then I can say seems like binomial coefficients. I think that's Pascal. I don't think so. 3, 6, 1, 2, 3, 4, and 10, 6 from the 4. All right, so here we go. Triangle numbers total plus equals current row. And then current row would become 2. Next time through the loop, add 2 to the running total. then add 1 because there's 3 points in the next row, and add that to the running total, then 4 points in the next row, and then add that to the running total, and so on. And I guess what they want us to do is print C followed by, I don't know, it looks like they wanted a tab, so let's get fancy. Followed by triangle numbers total. And then we'll return triangle number total. Now print 5. Let's see if this is right. 1, 1, 2, 3, 3, 6, 4, 10, 5, 15. Looks pretty good to me. Now, you may have noticed that this is actually perhaps a little bit of a simpler problem than it seems. I got really excited for a second because I thought this was going to be a little bit more complicated than it is. But basically, all it's doing is just giving you a running total of all the integers up until a specified integer. Let me see. So it looks like it's being fancy. Print out the triangles with proper spacing. No, we're not going to do that. All it is like, okay, 1. And then what's 1 plus 2? Then what's 1 plus 2 plus 3? What's 1 plus 2 plus 3 plus 4? 1 plus 2 plus 3 plus 4 plus 5, and so on and so on and so on. That's all it is. So we could simplify this with, sorry if that came out rude, I apologize. Print out the triangle with proper spacing. Wait, I'm not even sure what do you, like, did you want me to draw the dots? Because I don't want to do that. So I'm going to make a different version of this that's just a lot simpler. And if this simpler version, V2, just confuses you, then just ignore it. It doesn't matter too much. But really all we're doing is like have a counter, except we'll have the counter start at 1 while C is less than or equal to N, because I want to start from 1, not 0, and sum up all the numbers up to and including N this time. So then what I'll do is I'll print C, and I need, there we go, plus equals C, running total, C plus equals 1. Oh, and I guess I got to call the function. Version 2, 10. There, that's all. So it's actually a simpler problem, but it came across a little bit more complicated, I think, because they were giving it like a formal definition as a triangle number, even though really it's just, you see it even says here, the nth triangle number is the number of dots in the triangular arrangement with n dots on a side and is equal to the sum of the n natural numbers from 1 to n. That's all. Is that what it is? Yeah, but this is Pascal's triangle. Oh man, look at these. Look at this vector. Look at these vector graph. Wait, actually, I don't know if they are. Are they pixelated? I can't zoom anymore. Maybe it's not. Maybe it's not. But anyways. All right. So here's what I think I'm going to do for the next bit, because I went longer than an hour, but I think that's okay. What I'm going to do, well, actually, first, I guess I'll stop the recording.